Hello, I'm Susan Nash, AAPG, and I'm really happy to be here today to be able to introduce you to Dr. Mohammed Solomon, who will be talking to us at Your Tech about his new technology. But first of all, I'd like to introduce you and ask you to tell us a little bit about yourself, Dr. Solomon.
Good afternoon. My name is Mohammed Solomon. I'm the chairman of the Petroleum Engineering Department at University of Houston. I've been chairman here for the last 8 years. Actually, I'm the first chair of the department. I have bachelor degree from Cairo University, master's and PhD from Stanford University. I have been involved in fracturing and analysis of data for 40 plus years. I did much of my work in fracturing. I'm actually been elected the legend of hydraulic fracturing in 2023, last year. I also a member of Hall of Fame for Heart Energy, this new thing. I'm also a member of National Academy of Inventors, and I'm a professional engineer as well. I've been teaching and doing research for the last 12, 13 years. But before that, I worked in industry for Halliburton Company for almost 32 years or so. The technology we developed, actually, we started several years ago when I was working in industry. We were doing Wavelet Transform. What is Wavelet Transform? Wavelet Transform is a mathematical technique to analyze data, where you have in itself data. When you measure pressure or whatever data we measure, information, a lot of information about the system is embedded in the signal.
Mhm.
And the idea here is to analyze this signal. And in many cases, it's just the pressure, sometimes the pressure and rate or temperature, to get new information about the system. Wavelet Transform mathematical technique where we look at the data alone. There is no prior assumption of what we're doing. Wavelet Transform was started first several years ago in discrete Wavelet Transform, but we found to have many drawbacks to it. So we just last couple of years, we moved into continuous Wavelet Transform.
That's
We
really fascinating. Do you mind if I jump in really quickly? Because
so
what's so fascinating about this, it makes me think of Fourier transforms and acoustics. It makes me think that maybe you're doing something with acoustics.
Well, we can do acoustic too. The big difference of Fourier transform versus Wavelet transform, Fourier transform does not look at time at all. So when
Okay.
you see an effect, you don't see it, and you don't know the time. With Wavelet transform, which is a newer thing, is looking at the signal as well as what you have, what changes you have in with time. And it's very
Okay.
important for us in analysis of data is to know when things are happening.
Oh, absolutely.
So obviously Fourier transform has a lot of applications. It's a very old technique,
Yeah.
after Fourier, which was many, many years ago.
It's so
So,
fascinating. So in the
so
wavelet transforms, so you're basically able to identify the patterns. What type of analytics are you using?
when we wrote our own software to do the analysis, you can also use MATLAB, for example, for the analysis. But what we did is we looked at the data, continuous wavelet transform, for multiple applications. So one of the applications, for example, is determining fracture closure. This is one application we did, looking at fracturing events, for example, intersection of natural fracture, seeing closure or sand out, especially tip sand out. We can see that very well, growth and height. So various events during fracturing we can identify. We, we actually correlated our measured pressure to microseismic, which is extremely interesting. We saw when microseismic tends to move in different directions, saying the fracture is propagating right or left. We can see that with the analysis of wavelet transform of pressure. So I'm very excited about that. And we did one more thing that was interesting, is interwell connectivities. And
Hmm.
what we did is not only analyzing simulated data, we analyzed actually field data and we compared to current techniques. And one thing we did that I really like to mention is we looked at validated and verified our technology using strain gauges, where we had another group, that research group, that did measurements downhole using strain gauges, and our analysis, which relied only on data, very much agreed with it, 100%. So I'm very excited about that. And obviously, analysis of data is not a spreadsheet, is not simple. So
No.
what we decided to do is to build the software that we provide to people where they can use the technology we develop, and not only Wavelet Transform, but also we're adding some other technology that we have developed internally that are equally difficult to apply unless you have some software with it. And we are going to provide that software to people that are interested in using our technology.
Well, what's interesting about this to me is that there's a lot of work done to characterize um, fractures, especially induced fractures, based on geometry. But if you're doing the time and wavelet transforms with time, then you can actually model the behavior of the fractures.
Exactly, exactly. We actually we have developed multiple techniques before that. One technique we developed, we call it MRP, moving reference point, which has some similarity to what, or based on what Nolte Smith have done years ago, except that it takes care of some weaknesses that were original technique. So when we try to tell what is happening during fracture propagation with continuous wavelet transform, we found out we can also find all those behavior, and it does it without knowing anything in advance. That is the a big advantage. You don't have prior assumption, like many
Right.
times people will assume you have linear flow or radial flow. I do not need to assume any of that. And we have great team here at University of Houston. I have great students that are doing this work.
I love it. It's wonderful. And what I like about it too is that it has great applications for obviously oil and gas reservoirs, but also for all that's going on with geothermal.
Absolutely. I'm glad you said that, because we applied that same technique to temperature change in the Forge for, project. And
Wow.
it was very successful in analyzing the data.
That's great. Wow.
We are looking at doing Sonic 2. You mentioned that.
Hmm.
This is our next step. But I have students that are really working very hard, very really great students that are developing the technology.
Oh, that's wonderful. Well, Dr. Solomon, it's been such a pleasure to speak with you, and I'm really looking forward to hearing your presentation at your tech and also finding out the use cases that come up in the future.
We are going to also demo the software if people are interested.
Oh, wonderful. Great.
Yeah.
Well, thank you very much.
Thank you. Thank you for hosting me.
You're welcome.